It's like I'm moving so many places.
Guys, if you take a notice, if you take a notice, the computers that you have, they're not recording right now. Okay? So I'm going to have Haley, Amanda, Bella. No, that's, don't touch the stuff that I told you not to. No. So now, Juan, over there.
Oh. Juan got evicted.
Haley.
Sorry, man.
Please.
Thought that had to happen.
Jared, over there. Do not touch the computers because I have them set up the way that I want them set up. Also, please take notice. No, over there. So remember we talked about being a 3?
Oh,
being
yeah.
a 3? Okay. So, Bella, Amanda, Haley, Juan, and Kaylee, you guys are going to be in control of the record button. The computers that you have open right now are not recording. Okay, they're also directed so they're looking at your work as opposed to your faces. Okay, so you don't need to freak out. It'd be weird. So now the only thing I do kind of want you to try to emphasize as much as you can is in your conversations, and the mics are all hooked up so that they can hear you and hear your conversation. Please try not to South Philly talking, go through off so fast, only Piney talks, okay? Make sure you are deliberate in what you're saying. The microphone will catch it, whatever you're saying, and if you find something that you're like, oh, well, take a look at my work. If you don't mind, just kind of throwing it up to the computer, the microphone, the camera, and then talking to your group as well. Okay? A little bit of a show, but it'll save me a lot of editing work later. Okay, right now we do have a warm-up. Took us a little bit to get there. In your notebooks, this is independent. The image is as dark as you can get it. I want you to come up with as many possibilities that can work.
Are we recording right now?
No, we're not recording right now. I have a main recorder going on. So, you have stick figures, yeah? You're going to see that some movements will work and some movements won't work. I want you to try to find as many movements that do work and tell me how. Where's your notebooks? Okay, go. Independent, this is just on your own. This is your own warm-up. This is getting our brains thinking about transformations.
Is there an original figure?
Yeah.
Any of them.
Okay. And then we just list which ones will work.
Any of them. I would prefer to use pencil in math class.
Are we allowed to use more than one
Absolutely.
transformation to get
Is there more than one transformation to use to get a pre-image to an image?
No.
Yeah. An eraser? You can call yourself an athlete. See, Riley will die for this one. She didn't have to. You grabbed with fingers. Got you. Come up with as many as you can. Sorry. Got one? I like how some of you guys are organizing your paper. Okay. about in the next minute and a half. Which paths are impossible? See how many you can come up with. Which pathways are impossible? Impossible. Oh, you already did. Oh. Explain that to me. Oh, you clarified this as your original movement. Does that only have to be your original movement? So like what happens if I said like figure D is your first one? Impossible, okay. All right, about another 30 seconds or so. What you got? It's like worse for you. If like this is harder to see, or if like this one's harder to see. Okay. Levanta las manos, por favor. Tell me who decided on an original figure? Who decided for themselves that they're like, you know what? A is going to be my original figure. Why? Why did you do it, Karen? Boom! Yeah, come on.
Better see the translation.
It'll help you better see the translation or the
The
transformation. Okay. How many of you did or who did not decide on figure A as being your original figure? You didn't pick A to be like an original figure?
Like I used it to start, but I didn't use it consistently throughout my
Ah, you didn't do that either? So how many pathways are possible? Let's start building a list. Let's start building a list. How many pathways are possible? Is that possible? Yeah. All right, cool. Go.
A to B.
A to B. Is A to B possible? Do we agree? Disagree? Agree? How? How is that possible? Rotation. Where would the center of rotation have to be?
The middle. Right below.
Where would the center of rotation have to be if A to B is a rotation?
In between the arms.
In between the arms?
Yes. Yeah. No, I think it would be
the
like
center of the body.
The center of the body, yeah. That's what I'm
Yeah.
Yeah.
right there?
Yeah.
Huh. What about if we were taking it very realistically? What if I said, here's my piece of paper, this is my transformation, where would the center of rotation have to be then? So if this is my coordinate plane,
That would be the origin. Yeah, the origin.
so like right here,
Yeah.
why?
Because they're evenly distant.
Because what are we trying to maintain? Equidistance from the from the, which give me a better word, give me a better term for that point, Kaylee. Not the origin, doesn't have to be the origin. The vertex, it's a three-word term. No, line of symmetry.
The point of rotation. What?
Center of rotation.
Center of rotation.
Okay, but yes, you all are right. You all were like, the vertex, the origin, the center. Okay, yes, I agree. We'll focus on our vocabulary. All right, so give me something else other than starting with A, other than going to B. Give me another transformation that works.
E to F.
E to F. All right, so let's go from E to F. I apologize, it's a little bit hard to see on the board, but
No, the way.
how is E to F possible?
No.
Who said, I heard it's not, why, Jared, do you say it's not possible? So E to F is not possible?
Because it's the, I don't know, it's the same image, but the arms are like, different. Can't do that.
So, I want everyone to hear it. I'm a little bit louder so the microphone can shut.
I said, it's the same image, but the arms are flipped, and you can't do that.
You can't do that.
They're not the same.
They're not the same image, all right? So, they're not the same image. Where the image is not a result of transformation from the pre-image. Okay? So I agree it is impossible. Do you understand the, yeah? Okay. Find me one that is possible.
B, F.
B to F? How so, Miss Waldron?
It's, maybe rotation.
Would it be another rotation? Haley, what do you think?
Yeah, rotation.
A rotation?
Yes.
Juan, what do you think?
Yeah.
Could it be a reflection?
No, could be.
No, it couldn't, 'cause
Ben, what do you think?
Because the arms are different. Like the left arm is like when you reflect it, it would be closer.
So if I were to reflect this here,
Yeah.
what would have to change?
Everything.
The arms would have to change.
And the legs.
What's the
And the legs. So Jared, go for it.
It could be two reflections.
How so?
You reflected it, like, for, I don't know, like this, say over the, say that's an x-axis, if you reflect it over the.
So if I give it, so if I reflect it over the x-axis, so then what my figure's gonna look kind of like this guy, that guy, that guy.
Yeah.
Ah,
And
okay.
then
Wow.
you can reflect it, like, again, just like that.
So give me.
I don't know. You can,
Okay, so you told me that this was the x-axis, and sure, we can make that up, or we can say that it's a horizontal line, correct? Because it doesn't always have to be an axis. Okay, so then how would I take my intermediate image and get it to my final picture? Where would the what have to be where? Stay on thinking. I'm gonna go to Capriati. The center of its body. So give me descriptive words.
Like, if you had a rotation point in the middle of its body, and you do.
Rotation point in the middle of its body. So I
No.
just kind of throw this guy on like on a rotating
No, like,
loop.
I meant like to flip it. I don't know.
So what word associates with flipping?
Reflection, so.
Okay. So with a reflection, what do I need? Line of symmetry. Where would that line of symmetry? It was just reinforcing what Jared was thinking. How do I take my red picture to make it into my erasers work too? My black picture.
Well, couldn't you do like a
360 degree turn. Where would that just
no,
get
like
you?
reflection, like across each.
360 degree reflection.
I don't know. Like, I'm trying to explain it to you. Like,
Okay.
there, and then there. Like, go around. And when that works.
I'm gonna tell you, B to F is possible. It does work.
By rotation.
No, oh, yes, it can. Immediately, from B to F, you can use a rotation. But now you guys stepped up the game. Okay, you told me reflection. So use reflection.
Didn't you do reflection twice over the x-axis and then the y-axis? So it'd be
Where would the axis? If it's the axis, then here, okay, if this is the x-axis, you know you have to specify where is the x-axis. Where's this line that I'm going to be reflecting again? You guys are not wrong. I'm just trying to get it. Use your language. Eichfeld, what are you thinking? You've been sitting there.
that's all I'm gonna say, that you can just
it once, then flip it twice, and then do another slide?
Yeah, then slide back to where.
So are we gonna call this the origin?
Sure.
Okay, so if that's the origin, we'll extend that, so where would the reflection then be?
The y-axis.
Yeah.
So it would be,
So
yeah, you know what,
would it be
someone
like a
draw it
y
for me.
reflection then?
I didn't drop my marker.
Like
Tap
that.
there.
It's alright, don't worry about it.
Would it be like a y reflection?
Oh, I wonder why we did that GeoGebra investigation. Good job. Where would you put the line that you know that the other reflection has to go over?
Well, start off here and then you reflect over the x-axis here.
Yeah?
And then say it's the y-axis, you reflect over the y-axis.
Okay, so then draw where you think that it would be. You can approximate, perfect. Good. Awesome. That's actually much better than
That's
mine.
not a reflection now.
So now, if I
Not a
take
reflection now.
this away, that's not a reflection? Why wasn't, honey?
Because that would be a transition.
Hold on,
No.
so
That's
from
not
here to
the
here,
Yeah,
from
right.
here to here,
The arms are different.
No, they,
No, they're not.
No, we're not.
this, I erased it too soon. This,
I think it was sliding.
this was a reflection
Flip that around.
from here to
Yeah.
here. So now they're taken from here to here. Okay? So I'm going to kind of erase my
That
middle.
was drawn differently then.
No, you was
So
right.
arms.
No, you're right, you're right. No, it was,
Yeah.
it was.
It was,
You're right.
Well, Pocket Rucker's making me doubt myself.
Pocket Ruckers.
How many of you are
Guys are
disagreeing with
getting
Pocket
today.
Rucker right now? Okay.
it looked wrong originally.
So, it was probably just my image. So then now, can we take this first, or this second intermediate pre-image and get it to my final image? Yeah. Hey guys, guess what? Through a translation, you're absolutely right. If I were to have taken this image and flipped it over the x-axis, couldn't I have just used
That's what I was trying to
that
say.
for? Didn't. Okay.
That's what I was thinking, but I didn't know the correct like term and how to word it.
How would you now word that, now that you see it?
You put the line of symmetry through the body and reflect it over that line.
Okay, linear symmetry, vertical symmetry through, vertical symmetry through the where of the image, the what of the
The
image,
center.
the center of the image. We have to, in math, it's not just numbers in this class, ever. It's not numbers ever in math. It's literacy, it's language. It is a vernacular. You gotta know the vocab and you gotta then use the vocab. Okay? So, I am extremely confident that you guys are competent in the trickier transformations that you're going to be dealing with today. Alright, do me a favor, all of you, the individuals that I asked, if you can please hit record.
What's in
Okay.
that?
1, 2, 3. 1, 2, 3. Nope.
You should have put it over.
Is it happening? Now it's happening. Okay. 1, 2, 3.
Oh, yours.
1, 2, 3, 4. Take a moment and read this, please. 2, 3, 4. Just let you know that your hair looks great today. Thanks for doing it. Okay. All right, trickier triangle transformations. Try that on for what's that called? A homonym? What's alliteration? There we go. Okay. Read this through yourself as we read it together. There are many ways to transform an object in 2 dimensions. Some of them are to rotate it around a point, reflect it over a line, slide it along a vector, or decrease or increase its size, called a dilation. Rigid transformations are ones that do not change the size of an object. Dilation isn't a rigid transformation because it does change the size. That leaves us with rotations, reflections, and translations. To solve this problem, you can choose from this limited list of transformations, as noted below. Okay? Study the picture below. Examine how to transform triangle ABC into triangle DEF. You can use as many transformations from the list above, but be clear to show your work in each step. Make sure that you give the equation of any line of reflection, the vector of any translation, or my favorite part, the matrix used for both reflection and rotation. I forgot to make that edit. Reflection and or rotation. List the coordinates of the pre-image and the image in matrix form to defend your work. This transformation can happen in a variety of ways. Many, many different ways. How many unique methods can you come up with? Okay? Bonus. There is one way to do it in 2 steps. Can you figure it out? Okay? Before you get started. No. I know all of you are like, I'm an honors student. I need to do this now. Okay? Calm back. You can start thinking and let it churn real quick. I want you to help me out. Help us out as a class. And we're going to go through a little bit of a thought process before your individual thought process. And we've done it, in discussion before, maybe not so much on paper, but here we go. Raise your hand. What do we notice?
I have a question.
I have an answer, hopefully.
Why are the points not like A prime, B prime, C prime? What are the different?
Because I want you to use A prime, B prime, C prime, D prime, blah 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 blah, to transform it into DEF.
Okay.
Okay? That was just I don't know. Okay. So in this task, what do you notice? What do you notice? Misto. What do you notice? Anything.
Or 8.
I would actually call into Amanda's question.
There's 2 separate triangles.
2 separate triangles. Okay? So you see 2 separate triangles that are similar.
Yeah.
Wouldn't they be the same triangle or congruent?
They have to be
You're just trying to
congruent.
get to it?
Very good. So you know that they're congruent because what type of transformations are we focusing on? Rigid transformations. Okay. Also, I think a great notice that you picked up was the fact that it was ABC and DEF, as opposed to what are we typically using with images? Primes. Okay. So as opposed to A prime, B prime, C prime. Okay. What else do you notice? Anything ringing into your head that you absolutely would have to use?
Reflection or something.
Okay, reflection of some sort. Anything else that you notice that you're picking up right now that you have to use?
Rotation,
Why?
because it's not facing the same direction, so you use reflection, but you also have to, it's not to that sideways position.
So you know that there's going to be getting something from sideways to right up. Right, you're going to have to use a rotation and or a reflection. You're absolutely right. Good. Good. Okay, what are we wondering about? What are we thinking? What is going through your mind as you're looking at this task? Why is there a point on 0, 1? Why does 0, 1 exist?
Or 1, 0.
1, 0. Thank you. 1, 0 on the plane. That's a good question. What's another one? What are you noticing? What's going through your head right now before we really get started?
No, he said, probably have to rotate it, and I said, you can't.
You're probably gonna have to rotate it. You said you can't. Okay, well, it's gonna be a discussion that we're gonna need to bring up into.
That we're not gonna be, always reflecting over an axis.
Sometimes maybe the reflections aren't gonna be over the same line or over an axis. Reflections over axis compared to a line. Anything else really like striking you right now with you're not sure or that you think you'd be uncovering as you're doing this? Allie, what are you doing? You're kind of tinkering over there.
I was thinking about, can you reflect over half points?
Reflect over half points?
Yeah, like over
That's
half line.
That's a pretty good question. Can you reflect over half points? Fractions of, so rational lines? I know what you're trying to say. I'm not sure I'm communicating that very well. Basically, the points in between the actual hashtags of points. Hashtags? Crosshairs? Whatever. You know what I mean. Okay. So, how many of you are just itching right now to get started? I know you are. Okay. We are going to do a think, mini pair, big pair. Think, mini pair, big pair. Share. Whatever. So, you're going to spend 7.5 minutes-ish on your own. Then you're going to spend about 3 minutes comparing it to someone that's next to you in the group. And then you're going to talk whole group. Okay? Whole group. Next to. Oh, you're not supposed to be next to anyone. It's okay. It's fine. I made Rucker and Kaylee my pocket. Pocket Kaylee. Pocket Rucker. Alright, guys, go. Work. Show your work. I'll be around. I'm coming around with paper if you need it.
You have graph paper?
I have graph paper if you'd like it. Come up with as many transformations that you can.
We're starting from A, B, C to get D, right?
Absolutely, that's what it says. Right on that first line, how do you get transform triangle ABC into DEF? That's okay. Extra paper if you need it, but sketch away, sketch away, sketch away all. Graph paper, my sir. Welcome. You're welcome. Any more graph paper, guys?
Yeah.
What are we thinking? We're doing okay? Graph paper?
Yeah.
Okay, you guys want graph paper? You guys are in front of me. Okay. Anyone with graph paper? Anyone graph paper? so you guys can start talking if you. It's alright. That's what I kind of heard the mumbling. So don't feel like you are restricted. Okay, just because I gave you that 7-minute time limit. If you need some help,
Yeah, I just need translation over to here.
make sure that you're supporting your work though. If you are doing these, and I see a lot of you doing the reflections or doing your transformations first, so that's what I'm noticing. Make sure that you can back it up with the math.
First of all, reflected it, and then I was gonna.
So I didn't really more.
So what are you talking about right now?
I think it would've lined up,
I tried to reflect it.
There you go.
Perfection, after you were. Let's go around the table.
Yeah, but I'm not right.
Well,
I wrote the
translation
next
only happen in one direction.
Yeah.
I'm sorry, translation only happen in one direction, or can you manipulate?
Rick got another triangle.
You reflected it over as a Y.
Yeah.
Okay. So
You can, and then you just do.
okay. Why don't you work on your idea?
Points toward.
Yeah, but how would I fix it with that? You get it.
We're exactly last time there are a billion ways to do this, there are a billion ways to do this.
Why?
Well, that's why I rotated it over here, so that I could
Your
reflect it
idea is
then.
of the rotations and reflections and translations. And just go with what makes sense to you. Cass's way is not going to be Kara's way. I can tell you that.
Is that
It's right here, camera. No one shoot. Oh, wait.
Did you? Oh.
Yeah, you gotta ignore it here. Good job.
No, I actually.
Good job. I heard a good job. Pocket rocker got a good job. Did you?
to the right 3.
Of course he did.
Then you'll have this image,
Yeah.
and then you.
I want you to verify this though.
Around 8.90.
So because just your drawing isn't enough.
Line, you rotate it around.
Okay.
With the alright, with the bonus. beats,
Boom. I like your idea.
So like the math.
What are we thinking, boys?
Rotate it.
You translate the original image 3 spaces.
Okay.
And that would be.
Okay.
And then you rotate it around 8 prime, 90 degrees.
Okay. Love the fact that you're bringing the magnitude and direction. Good job.
It's right in between point A and point
Okay.
B on the two different triangles.
Where?
These-
Okay. So now I think that your plan works theoretically. Can you support it and back it up now mathematically? So now with your translation, now with your rotation, then your reflection, you're bringing in 3 transformations.
If you
All of which we support
maybe
through
to look at this, ready?
matrices.
From this point, and it's a circular.
Okay, so grab a piece of paper, work out your plan. I want you guys to come up, see if you come up with a different plan. Okay? See what you can do.
No, look, it's like equal. Like the,
And also make sure that like this is not
no, in a circle,
congruent.
halfway.
Like, you make sure that it's congruent. Go for this. I like your plan. I think that your idea could work. Now you gotta support it.
The point is point Z, that's what I'm labeling. Point Z.
So I'm thinking that developing our plans is what a lot of you are doing first, and then you're gonna do the math afterwards. So I'm going to be putting up on the board right now some of your reference matrices, just so you can support your knowledge when you are developing your math. Okay. So rotate it.
Now talk about the half. Alright, I'm gonna rotate around the left A over the half like this, like Erica did. And you rotate it over A, and then translate it up 1. See how there's like the half point of the line? If you reflect over half the line, if the line's A with D, A's 1 point off. So if I tried to reflect it over a whole, that would work. Reflect over
this is 7, and this is 2, so that would mean this would be 1, and this would be 6. So it would be,
I mean, 180, yeah. No, that would be.
so 1,
Remember magnitude and direction for your rotations.
No, but I think whenever somebody has
Well, I'm using.
this point is like.
About those ones. Are you sure sign off this week?
There's not anything like that.
Alright, well, what happens if we rotate it around this pole? Where does it end?
Yeah, but.
That's what I started, yeah. And then you did.
My mystery point C. Like named it.
That's actually.
D, like the bottom there.
Bottom
Like,
there.
we're everything that way.
And then this would be slide up. Yes.
So I'd be in the almost.
So C is negative 6 then? Negative 7.
Yeah, I'm not saying it's the only step. It might be first.
That's the full image for that. So how do we do matrix?
Okay, that's a big old sigh.
Alright, well, if we rotate, I'm trying to figure this out.
Well, I'm sorry for not providing that to you earlier.
This rotation right here is.
If
Where's
we
your notes?
rotated around point C, where would it end?
Of course you can use your notes.
My brain is not following
Is that the one?
this. Mystery point C, that's what I labeled.
Yeah, but you also have to support it with the math.
1, 2, 3.
You would you have 15
This
minutes.
would be the base of it if you rotated it.
I want you to,
Get everywhere,
huh?
but I won't get everywhere.
You're not going to get everywhere. It's impossible to get
What
everywhere.
if you rotate it?
Okay. So make sure you perfect your way and verify, not perfect, but verify your way.
Is it what?
If you were to flip over half point of
Did it? Let me see. I saw hands up. Talk to me.
That would be.
But I think I know what I did.
Yeah.
It's like this, 180 degrees to here.
And the right here. And then
We are trying to get ABC.
Lie down.
And it would be in
To right one.
X-axis.
But could you still use your same
Well,
pattern?
you were saying that.
Yeah, but.
How, using your method, do you go from ABC to DEF?
Is 2 translations considered 2 steps or is it 1? If it's down and over, is that 1
You could use a vector.
Pocket rocker. Okay.
Alright, well, how do you go?
Oh, yeah, vectors.
From here, you told me to rotate and then reflect, yes?
Here.
So then how do you go from here to here? And then rotate. It's the same stuff, like just in a different direction, different order.
I just gotta put it
Okay.
in. Because you just gotta-
Now,
What would be
make
the
sure that
vector?
we're also remembering that our the main direction is always going to be counterclockwise.
Yeah, but the vector has what button?
Counterclockwise. So if we're going to go 90 degrees clockwise, what does that do?
It doesn't make it need a vector before you can do
Ah.
7 negative 2. Yeah, because they're negative.
Negative 270 with that. 270 degrees. Counterclockwise. Good idea, guys. Good.
I don't know, I tried.
3, 8.
Well,
We're at this point right here where we rotated around point Z.
first of all, I think we rotated about point C.
The first thing
Point
was
Z is
this.
this one. There.
Okay.
So we rotated it
The first thing that I did was this, and then I was like, wait a minute, he's not even in that. And I was
Why
like,
do you have to use C?
I'm just trying to figure it out. I like, this is my solution, I'm just trying to figure out what this is.
Okay. So number 1, is your solution her solution? Does it have to be? So for Vada, I'm telling you, verify your solution for yourself to see if your solution works. Okay? Now for the rest of you that are like, I need Z, what's going on?
I figured out hers and I was trying to figure out mine.
Don't worry about figuring out hers, she has a brain, she can figure it out by herself.
Alright, well I know it's right. I flipped this over and then I was gonna try to.
So you went here to here. So erase hers and create one for yourself. Well, unless you guys collaboratively came up with it together.
Well, she can always put on the tab, we were collaborating.
Mine has like 17 steps.
Okay.
Eventually I got to it.
Okay.
This is gonna be a pain.
Before we go
A lot of
collaboratively,
work.
verify. Come up with your own solution and verify. You have these matrices. We are practicing with the matrices.
Mercy.
Defending with the matrices. Sorry, I haven't even remembered this yet. What are we thinking? I feel like you guys are all like independent and haven't been talking to each other. A little bit here and there. What are your thought process? What's going on in your head?
First I rotated this here
Okay, yeah, all of your solutions are definitely different. Okay, so we'll go with my step first. What were you thinking? Okay, so if you reflect it, absolutely, I do see that your line is drawn right here at that.
I used
what's that,
four
next to
steps.
the
I don't know how to back up.
What point would you have to rotate it about in order to do this? That point right there. Okay, so then,
separate from right.
now you're not gonna be able to verify the, you're not gonna be able to verify your,
Negative BA,
Again, it's
right?
back to that point though, without.
Isn't that like the,
with, you're not gonna be able to verify the rotation matrix.
Oh, yeah.
Okay, will that work?
Had to use those. Oh, yeah.
So you have to,
Negative won't
so
work.
then now you have to come up with a way that's going to prove that it works, and if it does work, you can come up with a different solution.
You're doing yours.
Okay? Well, you might not be able to do it. Okay.
Oh, and I know, I did it. And then you translate it, and then I get it. I got it. Okay. Should I show?
Mhm.
Well, that helps.
Where are you going, above Z?
Okay.
Or you just rotating on the axis?
So, the reflection, the turns, and the slide, I think, I think this can be combined, but I like this plan, I like what you drew. So I wouldn't try and I wouldn't try and beat the system by coming up with like, oh, well, how do I go from my pre-image to my image? Don't try and beat the system. I would say work with the system that you developed and support it.
And then
Please.
I would want to translate it
Okay.
over, like, again.
Same thing, all right, now what are you stressing out over?
XBs, and then do the same thing for.
Okay. So the line of reflection is the y-axis. And it worked. Awesome. How did you know?
It should be the same image, just in a different spot. I got it.
Boom. Can you say that a little bit louder? That was awesome. So that make sure your what do you rotate? 90 degrees, 180, 70. Awesome. That's really, really, really. And you can verify it mathematically because we aren't using the origin as the
That'd make a lot
matrix center
easier.
rotation. That is really awesome. Negative reciprocals, but
And then you will then flip.
No, that's, no. 90 degrees
So,
clockwise.
your first goal is translation. So we always have to start with what? Matrix? Start with your original image, your polygon matrix.
And then
Develop your
make
polygon matrix for triangle
with that one.
What are we thinking? Go ahead, keep it out loud.
What do you think?
Okay.
Isn't it in that way you gotta use whatever your answer is for the first one and the second, and the second and the third packet?
Oh, goodness. Okay, keep going. I lose track of time. Good, I love the fact that you're organizing it too. Awesome. So that's your polygon matrix. Now our polygon matrix always goes second in the order of multiplication or addition or whatever. So what's your transformation matrix? It's gonna go right in front of it. What transformation are we doing? A translation. So what's happening to every single point? What's happening to A and B and C?
Which comes first?
You're adding it to 3 in the what direction? Positive, right direction, okay? So are you changing your vertical? Are you changing your y at all? So what's your transformation matrix going to look like? 3, 3, 3, 0, 0, 0. So,
So
please do
for
this when you're open.
this, you put the original point.
Allie, what are you working on?
Yeah.
On matrices.
You're adding, you're translating, you're translating. So in your x's and your y's, because these rows have to match up, what are you doing to
Are they
match?
matching up on?
3 to the right. So what mathematical operation supports 3 to the right?
Right here, I got -1 and 2.5. But it's really the 1. So I think I'm gonna have to do like.
Yeah. In what row?
Just gonna have that on
The top of the X.
Very good. So you're gonna do plus 3. How many times? Why? Points that we're moving. Okay. So now you fill in the bottom row. Okay. So now taking this matrix and adding it to this matrix that are exactly the same size dimension.
0, 2.
Testing.
Okay. So now check A prime. Is A prime 1, 0? You're right, because you did a little math wrong.
That's where I am.
What's 0 plus 1? 1. So is A prime at 1, 1? There we go. All right, so
Yeah.
continue. All right, ladies and gentlemen, we got 5 minutes left. Yeah, honey.
So now all I have to do is. Yeah, I actually did that faster than I thought.
Why don't you explain it to the other member of your
It's a
group,
long step, but
and
it's
we
not
can
that
whole
bad.
group discuss it.
And then, what's the,
If y is negative x, y is negative x.
Yeah,
And 2. Okay.
pretty much. Actually, it's not
Y is negative x. So x is negative y. Y is negative x. X is
no, I know that's
negative y.
negative x equals y, I don't know, but.
Matrix support it. Well, because you're flipping, and this is linear algebra. Okay, mind you, this is higher. Okay, like college higher. On the main diagonal, 0, 0. It's because the main diagonal needs to be zeros because what you're doing is you're actually flipping and switching your x and your y. So if y is negative x, y is negative x, y is negative x, negative 1, 1.
Okay.
Y is negative x. Y is negative x. Yes. So this would be,
I think it's
yes, main diagonal. Okay, ladies and gentlemen. Well, I want to bring this in real quick, and I know we are running out of time fast. Does anyone feel confident or feel that they have a specifically unique solution that they find interesting that they could possibly discuss with the entire class real quick, briefly?
Pocket people. But I don't have the math for it.
Okay, you don't have to have the math for it right now. I'm going to adapt and make sure that the math is due tomorrow when you come back in class. We don't have class tomorrow. Awesome. Yay. Cool. Wednesday. Thursday. Okay, so I got Pocket Kaylee.
Wait, so we have to finish this?
Yeah. No, it's just because they always come up with like the
7 triangles on it.
Okay, so Kaylee, if you don't mind, right under the document protector.
Cool, now I get
Anyone else have something interesting that they would want to just share? It doesn't, whatever you find unique.
I think mine's gonna work, but I'm not sure.
Okay, then I'm gonna have you take it up there. All right, so Caitlin, take it away real quick.
What?
Louder, too, girl, because.
Alright, what else can I stuff? Okay. I rotated ABC around point -1, and I did that by finding the opposite reciprocals to make sure there was 90 degrees for a 90-degree rotation. And then I reflected it over the y-axis.
Yay!
That was
Absolutely.
unique steps, too.
I proved it with my muscle.
Yeah.
And she proved it with her awesome cyborg matrixy stuff, which is awesome. Love it. Love it, love it, love it. Great job. Someone else. Pocket Rucker, go for it. He is, Rucker, just noticing, is wearing a Rucker shirt. Good call, Katie.
That one.
That.
All right, so discuss.
Okay.
Sit down.
So, I would multiply it over the negative x equals y axis, and then you get this triangle. And then you just translate it right to points.
Awesome. Awesome. So he's using the y is negative x line. Awesome. Anyone else? Something unique? Allie, go for it. Polly Pockets. Okay.
So I reflected over the half point right there.
X equals 1/2. No, I'm sorry. X equals negative 1/2. Girls.
And then I got this triangle. And then I rotated over A prime. And I got this triangle.
Direction and magnitude.
Yeah. The 90
What direction?
counterclockwise.
Very good.
And then you translate up one.
Very good. Love it. Love it, love it, love it. All three definitely unique solutions. Now, the bell's going to ring in a moment. Do not get rid of me just yet. Individuals, can you please hit your record button again, please? All right, we all hit the record button. All right, so wrapping up real quick. Hold on, no. Stop it. It's lunch. You guys have 10 to relax. You have an hour. So, ladies and gentlemen, we do not have class tomorrow. However, what are we taking on Thursday? Our tests. Now, I am giving back individual specific critique on all of your documents. All right, I've made my way so far to Rucker. And you're gonna see, I want you to resubmit in a different color. Study, your test is on Thursday. And you're also submitting this triangle transformations to me on Thursday as well. Love you, bye. Mwah.
What do you mean by? Wait, a different color.
You're gonna
highlight everything red?
You're gonna see,
I just added to my document.
but in a different color.
I didn't.
No, you'll see mine. You'll see.
Oh, that
where
was
they are.
fun.
I have to go back to the
Great job, thank you guys. Bring on always one at a time.
I already did my own Brittany. I didn't highlight the colors though, because I didn't know I had that.
Always one at a time.
Like on the GM, she's gonna edit on there, and it's gonna tell you what to fix because she highlighted it.
Do you think
So
that
when
she's
you
gonna wanna
fix it,
see
you gotta highlight it in like red,
solutions?
and it'll be like that's what I fixed. I didn't know that.
Cool.
I did. You're welcome.
Awesome. Thank you, Ben.
He left. I want to listen to this. He doesn't love me.
Yeah.
He loves me.
Yeah.
Steve Allen and Eric Olickman, please report to Mr. Cash's office. Steve Allen and Eric Olickman, to Mr. Cash's office. Brielle Goliath, please report to Mr.
And I love that I said there was only one way, but they came up
Rainier,
with two more
David
different
Matthews,
ways.
Swan O'Rourke, and John Rainier. Please report to student services. Josh Gillette, please report to the main office.
And he really honestly just comes out with like this stuff. And I'm like, where do you store that? In your pocket? Like, what's up, guys?
So, was it a success?
It was a success. Thank you so much for opinion.
See? Was.
I can't wait to show this to my class because this is not how much students exactly like.
No, are you kidding? There's a reason why I picked those guys.
Yeah, but even if I pick my top guys, it's not like that.
Like sometimes even.
My problem is that we've got such a small situation. I've got 30 kids in every class.